And we are live? I think so. Yeah. Okay. Hi, everyone. Today we're gonna do day 5 of Advent of Code. And yesterday was quite pleasant, and I've heard bad things about this day. And we'll find out in a minute if that is true or not. As usual in the past few days, I'm actually looking at the chat, so if you join me and actually say something, I might be able to see you. Making no promises though. Um, so let's get started. Day 5. If you give a seed a fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter. I see. Okay, interesting. Sand filter. Um, okay. Ran out of sand to filter it with. Um, can't make snow with dirty water. Don't worry. I'm sure we'll get more soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. Uh, I've been too busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed towards over in that direction. It's much faster than your boat. Could you please check it out? You barely have time to agree with to this request when he brings up another. Um, while you wait for the ferry, maybe you can help us with our food production problem. The latest Island almanac just arrived, and we are having trouble making sense of it. Almanac is okay. Listing. Um, the almanac you're puzzling, but lists all of the seeds that need to be planted. It's also a list of types of soil, of what type of soil to use with each kind of seed. Um, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified by with a number. But numbers are used by each category. That is, soil 1, 2, 3, fertilizer 1, 2, 3 aren't necessarily related to each other. For example, seeds 79, 14, 55, 13, seed to soil map. 50, 98 to 4, and so on. Okay. Seed to soil fertilizer map. Okay, let's look at that for a minute. 0, 15, 37, 37, 52, 2. Okay. I'm not sure I still like get what exactly is this mapping thing, but we'll figure it out in a minute. By the way, I'm a little bit dumbed down now because, well, I've been drinking a little bit of wine, and that might affect my performance. No worries if that means it's less entertaining. I will totally understand. Anyhow, the almanac starts with the listing by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. Okay, so the rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section starts with seed to soil map describes how to convert a seed number, the source, to a soil number. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than a list, then list every source number, it is corresponding and its corresponding destination number. The map describe the entire ranges of numbers that can be converted. What? Ranges of numbers. Each line within a map contains 3 numbers. The destination range start, the source range start, and the range length. Consider again the example seed to soil map. So this is the okay, so destination range start of 50, source range start of 98, and a range length of 2. This means that the source range starts with at 98, contains 2 values, 98 and 99. And the destination starts in the same destination range is in the same length, but it starts with 50. So it's 2 values, 50 and 51. Okay. With this information, you know that seed number 80, number 98 corresponds to soil number 50. And that seed number 99 corresponds to soil number 51. The second line means that the source range starts from the second line means that the source range starts from 50 and contains the source. Okay, yeah, they are reading it backwards. So the source starts at 50, contains 48 values, 50 to 97. This corresponds to a destination range of 52 to whatever it is. That's 48 numbers down the line. So seed number 53 corresponds to soil number 55. Any source numbers that aren't map correspond to the same destination number. So seed number 10 corresponds to soil number 10. So the entire list of seed numbers and their corresponding soil numbers looks like this. 0 to 0, 1 to 1, 48 to 48, 49 to 49, 50 to 52. We continue on. And then 98 corresponds back to 50 because what? Yeah, 98 and 50, that's okay. 53. Okay, so everything is flipped backwards, which is annoying, but sure. So this is the list. With this map, you can look up the soil number required for each initial seed. Seed number 79 corresponds to the soil number 81. Because our seed number 71 is corresponding to whatever the lookup table says. Seed number 14 corresponds to 14, 57, seed number 55 corresponds to 57, and 13 corresponds to 13. Okay. So far, so good. The gardener and his team want to get started as soon as possible. So they'd like to know how the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. So if we go back to this thing, humidity to location. So yeah, we need to basically traverse all this translation table. Okay. So in our example, let's look at that. You'll need to convert each seed through other categories until you find its corresponding location number. In this example, the corresponding types are seed 79 goes to maps to soil 81, maps to fertilizer 81, water 81, light 74, temperature 78, humidity 78, location 82. Okay, and then we do this conversion, so on and so forth, and then we take the minimum, which is 35. And the question is, what is the lowest location number that corresponds with any of the initial seed numbers to begin your puzzle input? And yeah, okay. So basically, we need to first of all pass all of this into like a lot of crazy offset maps, and then just traverse them and just traverse all of them, find the minimum number that we get mapped into. That's it. Okay, so let's get started. So firstly, we'll just duplicate day 4 because this has been a very like a very well structured day. Here we've got day 5, and in our CLI, in our main function, we will use day 5 now. That will take us to day 5 run. We need to probably import that. And what does it say? It says invalid metadata. Interesting. So this is like Clippy being annoying. Cargo Clippy. And then we can say cargo Clippy fix whatever. Error. Working on the directory has uncommitted changes. We can say allow dirty. And it says we need to also probably say allow fixed. Okay. We seem to be trying to use match for destructuring a single pattern. Consider if let. Yeah, so basically, can I just let it like do the thing? It knows exactly what what we want. So first of all, yeah, let's just do this cleanup very quickly because I've been told Clippy is very nice, and if we stop it from being annoying, then it will actually be helpful for us. So where's our text editor? Let's use Rust Rover. Yeah, it does not know Rust Rover. So let's just do that. Okay, part 2. All LT. Oh, it's day 2, part 2. All LT. I mean, this and you used only. Oh, I see. It's only used this thing with which we don't need. So okay, next. Day 3 part this thing. And it says enumerate match this thing. Consider using if let. So match on anything. So if let can we just convert it to if let maybe? Convert match to if let. Oh, that's very nice. And let's continue on. It says day 4 mod rs. Also, we can say if let. So day 4 mod rs. Line 26. So let's try to use again if let. And day 5, it has the same complaints. So yeah, that should be good. Look again. What have I missed? So day 2, part 1, line 121. Again, a flat. Very nice. And day 3. Day 3. Part 1. Line 55, or what was that? Yeah, so if let sum. And here it says irrefutable if let pattern. So this pattern will always match, so the if let is useless. So replacing this with let. Okay, so day 2, part 1. Day 2, part 1 says irrefutable, so just let. And we can just say this. And Rust font is angry at us. Okay, that's probably nicer. And match on that. I'll go Clippy. And day 5 mod RS. Here again, we've got day 3, part 2. Day 3, part 2. I'm just doing this cleanup because, well, I should. And move on. And all we've got is day 5. Okay, so let's commit everything except for day 5, and then we will move on. So everything except for day 5. You know what? We can actually commit. Okay, Clippy. Back to actually doing the thing. So let's nuke day 5 mod, whatever it is. Day 5 mod, whatever this is. And for some reason, Clippy and the IDE is unhappy, but we'll just ignore that. And let's actually start with writing some tests, which is always very useful. By the way, testing is very key, like it's a key part on like making this thing kind of like converge sort of quickly. So we've got this. And let's figure these out. Can remove everything except for the run function, which we will need to actually implement. So let's do that. And these will be empty strings. And let's look at our inputs and figure out how would we approach all of this, because this is quite difficult. Okay, so first of all, we do have seeds, which is basically just a very small and not very significant thing. So let's just do that. Oh, I might want to commit that because um, uh, D5 scaffold. Okay, now we've got like a cleaner thing to look at, and like Git won't like noise. So fn parse seeds. Oh, we do need parse numbers. And apparently there's a nicer thing to use here, which is separated pair or something like that. Or just a minute, I will actually use like a friend that actually knows Rust sent me a very nice comment on like what would be a more idiomatic norm way to pass numbers specifically, or pass a separated list. I'm just gonna open that here. And while that is happening, and also he said that Rust is smart enough that we don't need to do this separation of U32. But that is not actually correct, or at least claims that it's not correct. Okay, we will see if this actually like fails us or not when we try to build stuff. So let's look at what did he send? Ah, damn. I'm gonna literally look it up here, and I will let you know in a minute when I find it. Okay, look up, and it says, where's the thing? Okay, so separated list 1. Okay, so apparently there's a separated list. Okay, so let's find that. Not here, not in sequence at least. Might be in somewhere else. Let's try to basically, so separated list 1. And this separator is going to be, in our case, space. So tag space and a U32. And that is going to be our input. That is going to basically be our number parser for today. So yeah, if we look at that, we only need to now, we need like our seeds is going to be a tag of seeds colon whatever this is, and then we'd need to basically pass all these maps and just throw them into a hash map, like each of these into their own hash maps. By the way, let's look at our actual input. Let's just verify it's like same. We've got the same amount, the same type of tables. Okay, so okay, these numbers are huge. It's going to be terrible to debug with our eyes. Okay, so we will need to write very good code. So pass numbers is okay. I hope that we can test that. So I feel like I need utility a utility library at some point, like a small utility crate within this project. So test pass numbers going to be this thing, and that is going to, okay, seems like a somewhat reasonable test. And it says redefined here. Oh shit. Yeah, we definitely don't want to have the same test with the same name. Okay, so our number parser seems to be working. Fn pass seeds, that's going to be a tuple of actually just going to be a preceded okay, so that's definitely not it. I'm going to return exactly the same vector. So it's going to be a preceded by tag seeds space pass numbers. Yeah, okay, so we've got our seed parser, and we can figure this out now. So where is it? We need to look at, okay, let's actually, yeah, let's just test the parse seeds thing. I really like the fact that Copilot is assisting us with like all the boilerplate crap. So parse seeds. Yeah, that's definitely, that looks good. Let's rerun that, and very nice. Unused variable default. Yeah, okay. We still, yeah, we definitely haven't used our input yet. Okay, moving on. What else do we need here? Let's try to figure out how do we build a map. So if we look at any kind of map here, first of all, we need to find each map. Like we need to say seed to soil, blah, 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 blah. So we'll find that in a minute, but we do want this basically. So we've got a map new line and then these sequences of numbers, but each number is, every time it's exactly 3 numbers. And each number has a very different role. So we are going to pass them and throw them into our translation table. So let's formalize that. We've got pass map. So pass, they had a thing, they call that something, right? Category map. Category map. And this is also going to get a string of inputs, and that is going to return us a hash map of ranges. We do not want to actually... Ooh, interesting. So instead of actually storing this in a huge table where we fill up these gigantic ranges, which just take up a whole lot of memory, we can store these ranges in a sorted container and just look within that sorted container what is the offset for each range. So that's going to be basically a map of differences. So yeah, this is going to be the thing. Okay, so how would we do this? Let's actually visualize that. So we've got let's look at the smallest yeah, this is God damn it. There it is. So this is our seed to soil map. We can try to figure out what's the best demo for it. What's the best way to think about that? So we've got a map that needs to, we need to map between 98 through 99 to 50 to 51. And we do need to, we also need to map between what is it? 50 through 50 plus 48, because, well, I don't care about that. And we need to map that into 52 through 52 plus 48. So this is our map of range, like this is the map of ranges. We can try to sort these, and instead of actually saving all of this huge data, because, well, I don't know if you've looked at the terrible numbers that they had here, but our puzzle input is actually like terribly big numbers. I I believe that's on purpose, so you won't build the static hash map out of these. But basically, that means we cannot trust, we cannot like actually fill this continuous range, which we also know that we don't care about that continuous range. So how do we do this? So given that we've got any kind of seed number, let's say 79. So 79 maps falls within the range of 50 to 48, which maps us into this range of 52 to whatever that is. And that basically means that all we need to know, except for the fact that basically, okay, so this range only has a difference of +2. So that just gives us a +2. So that basically maps us out to, well, um, let's think about, yeah, so like this range is basically, we don't care about that. Okay, so basically we just need to somehow know that because 79 falls within this range, we just map it to +2, which gives us 81, and then we can continue forward. I think that's it. So we basically need to somehow map an integer into this range. How would we do that easily? We don't have a lot of ranges, right? We have, I don't know, less than 30 for each of these things. So 30 ranges. How do you do a map of ranges easily? I mean, we could test them linearly because there's just not a lot of seeds actually to do the lookups for. But it is going to be nice to just have a map that does that for us, a function that does that very easily. So firstly, we could sort all our ranges, which is basically we've got 0 through L1 through L2 through L3 until basically I32 max. And each bucket is going to give us like an offset. How would we do these buckets easily? We can always just have an array and like find the smallest step, but also I would guess that they would be horribly terrible towards us and give us like a very crude step size. Like the smallest step size is going to be too big. So let's think about it for a minute. Hi there. I don't know who is watching, but hello. Um, or we can just do the linear probing for each thing here. I mean, but that means we need to do that for each seed. For each seed, we're going to, let's actually calculate how terrible is that for the lookup thing. So we've got, I don't know, let's call that 20 seeds times 20, not plus. So for each seed, we're going to do this. So we are going to do 20 lookups and then another 20 lookups. I think 20 is a good approximation of the amount of the size of everything here. Let's go with 30. So 30. So we've got about 3,000 lookups to do this. This is actually not that terrible. If it's 3K lookups just to map from one thing to one thing, that's just a very small number. So we can just do that, and like the lookup is basically just one subtract the other. I mean, I would be happy if we thought about a better range container, basically, but yo, Ran. You're such a king for like attending these live streams. I really appreciate you for that. Um, so there should be like a very of one solution for that, and I will just brute force this as a terrible person, and people will need to excuse me. So we are going to build our own structure, which will be a very terrible range map. So let's build the struct. So struct, that's not going to be a hash map, it's going to be a range map. So we've got ranges of, well, by the way, maybe we can do that, one thing better, and that is going to be, maybe we could insert, let's think about maybe inserting this not to a hash map, but into something that's a sorted container in the first place. So Rust standard containers. So standard library containers. Collections. Okay. So we've got the vec the queue, linked list, hash map, B-tree map. Okay, so a B-tree map sounds very nice, and a B-tree set and a binary heap. Okay, so I think a sorted container would give us a very good performance for actually looking up, given that we probe something. And the best thing that we could do is to somehow, instead of actually doing the lookup for an exact value, we want to do the lookup for, well, the closest value. So we could try and find not the actual value, but find the next value closest to it. Let's see if this map has actually this has this kind of thing. So first of all, you've got, let's see, what is split off? So split off splits the collection at a given key, returns everything after the given key, including the key. So we've got B-tree map from something to something, that's okay. And we split off at 3. Can we split off at a key that does not exist though? Or, oh, lower bound. Okay, that's the one. Nightly only experimental. Okay, I think we might go for Rust Nightly for that, because this is a very, I think this is exactly the thing that we want, because we've got a sorted container and we need to find the lower bound for each key, because we are going to look within range. So I think this is actually, this is going to be the way for us to do this. We are going to find the lower bound for each array. For each input, and that means that we are going to do a O of log n for lookups for bounces for each number that we look within each B-tree map, which gives us, well, 2 lookups, 4 lookups, because well, we are on, as we said, we don't have a lot of things going on here. We have 30 keys, so log 2 of 30. Yeah, so we are going to do on average 5 lookups, which is way better than 30, but it's not going to give us a whole lot better things to do. So do we want maybe to find a better container than B-tree map? Probably not, but I think that's good enough for us. Okay, so let's move on with actually constructing this. I really like that Rust has like high performance containers that we don't need to think about, and like thinking a little bit more about whatever this thing is gives us a better thing to do. Okay, so parse category map is going to give us a B-tree map between a U32 to an I32. And why is it an I32? Because we need to also support negative offsets. And the map is always positive. Yeah. Oh, we are actually, yeah, we need to, yeah, we need to, yeah, we need to store the offset. We don't need to store anything else. So let's continue with that. Okay, so this is what we aim to have as a result here. And we've got category map, which is going to be map new line. And then we will have a few things. So we've got preceded this thing. And here we've got a separated list again of tuple of three things, which is going to, we'll do the tuple in a minute. And just be perfectly clear about this, this is going to be a separated list of, how do we do this? Preceded. Oh, so we can say instead of preceded, okay, so let's actually just pass the triplet in a separate thing, just so we'll have a cleaner function. So that's going to be a separate function. Okay, so yeah, a pass category, and that's going to be terminated with a new line. So pass category is still not a B-tree map, but that's okay. We will find that in a minute. We will fix that up in a minute. Let's actually pass the category itself, which is just three numbers. So we've got, yeah, a tuple of U32 tag space, and then another U32, then another tag space, and another U32. And all of that needs to actually be syntactically correct. So we've got our tuple, we are running that through the input, and to make this, to map that into our actual insertion structure, we need to map that into a function that receives all of that and does something. The something that it does is not this multiplication crap. This needs to be something else. Let's think about that. So we've got, let's actually give them a better name. So we've got destination, we've got our range, and we've got our source. If I recall correctly, let's just verify that. So so the first line has a destination range start. So yeah, destination range start, source range start, and the range length. So let's maybe call that range length. And we need to compute two things, which is, yeah, we need actually, we need all of these. We don't need just the thing, because we are going to, oh, we actually do need just the thing. Okay, so we basically need to say, let's actually, yeah, okay, so we've got a tuple of, let's call that, we've got the source, we've got the map, and we do need to insert two things into the B-tree map, because we also need to insert the one-to-one offset, the zero offset, basically. So that's going to be, can we compute that? Okay, so we need the U32 of the length, we need, and let's just give ourselves a note. So returns source, um, source end, which is just the range length, and offset. And just so we'll have that clear, offset is destination minus source. I think so. Seems to be reasonable. So we've got all of that. And I32, yeah, I appreciate the casting. It says this casting isn't relevant. That's okay. And is that, by the way, not relevant? Interesting. Seems to be not a problem. Anyway, this is passing a category. So that is now passing a category, and we need to fold that into a B tree. So let's do fold many one and do all of this passing. We do need a B tree map. So that's going to be B tree map new. Cool. We are definitely not passing the input yet. Input is here. And we need lambda closure, which accepts the tuple from this category. So maybe let's actually just call that, let's actually have our category here. So struct, it will just give us a better like experience for actually handling this. So we've got category, and we can say now category. Can we change return type? No. Okay, so category, let's open that, and we've got all of that. Yeah, that's very nice now. And this category now, we can pass it in here. So we've got our category. Oh, that's our accumulator. So that's our mutable accumulator and our category. And what do we do in this category? We need to insert two things, as we've said. So definitely not that. Okay, so Copilot has definitely not understood like what we are actually planning to do, which is to say we are going to insert source with the offset, and we are going to insert category plus range length with not the offset, but with actually length plus 1, and we are going to insert the offset 0. And we need to return our accumulator. So this is going to be correct, I hope. And it says that range length in vec unknown. Why is it vec? Who said it's a vector? The preceded separated list. Oh, I see. This is actually, yeah, we are, okay, so we are doing this exactly once. Interesting. So instead of folding this like that, we might be able to, do we need to accumulate that into a list before we do this? Probably not, because it's a sorted container. We can just import that, like we can just do this easily. So how do we do this? So we can set up this crap. So we don't need this separated list anymore, but this is actually nice. These function takes blah, 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 and it, yeah, so instead of terminated, sorry, that's just not true. Terminated, yeah, just a new line. And pass category, this is going to give us a vector. But the vector means that we've already accumulated everything, so we don't need to do this. We can say just fold many here instead of all of that. Crap. So we don't need this fold, this external fold, and we can pass all of that here. So we've got our thing, and that's going to be our class category, which is terminated by a new line. And it is unhappy with me because I haven't passed the input. Okay, so we've got, let's actually look at that very closely. So we've got our terminated pass, basically our category. We can actually call that just category. Okay, so we've got our terminated category, which means that we are folding. Okay, so we are iterating over all of these categories until there are none left. We know that because we will have 2 new lines, and that's very nice because that means we don't need to worry about all of that other crap. So that's going to be our category map. So we should write some tests for that, right? Probably a good idea. So first of all, let's actually just test the categories. So hash test category. And how does category look like? What is it? Okay, things are not working because I don't write code. So we've got assert equal, come on Copilot, do the thing. So we've got this and our actual source length is going, okay, so our source is actually going to be 2. How's our map looking? So our map is going to be 3, that's okay. And our offset is going to be -1. Because that's going to be destination -2. Let's run that test. And we are failing because of a lot of shit. Expected function mute found this thing. Let's see, where is it? Why is it unhappy? Okay, so all of these look okay. So we've got tuple of u32 tag, u32 tag. Oh, shit. This thing. Okay, so we are, yeah, that was definitely incorrect. Okay, so we've got map from tuple blah, 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 blah into all of these. Is that now compiling? And it says expected u32 found i32. So offset can be, so as i32. It says cannot do this thing because I forgot to do unwrap or something, right? So unwrap would probably help. And we need unwrap dot 1. And it says that we need to at least derive partial equality. So let's do this, where we say partial equality, whatever. This is actually not important for our purposes. And it says expected category mismatch types. Oh, yeah, we don't need this okay thing. We can just say okay. And what? Cannot use formatting. Derive debug. Okay. So there is a reason not to derive debug. I mean, okay, so our tests are now passing. That's very nice. And let's now test our category map. So how would our category map actually look like? So for a very, very naive example of, well, map 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, that's very nice. But I'm pretty sure this is going to, so terminated by an optional new line. I'm happy that we found that now. And let's actually test that, put that to the test. How is our thing going to be? So we've got, let's go quite simple. So we've got 1 to 0. We've got so there are no overlapping ranges. That means that we should be okay. Let's try to compute these with no overlapping ranges. Or you know what? We know exactly of an example of no overlapping ranges. This thing. So we've got this. So this is our map now. And what would we expect this map to look like in our example? By the way, can we, is there like a B-tree map? No, there's not. That's quite unfortunate. But we can probably insert that easily with whatever this thing is. So let's actually have that here as a B-tree map between U32s and I32s. And that is going to be a vector of a lot of offsets. Not a lot, actually, just two things. So okay, so three tuples basically. So we've got a tuple between 50 with an offset of 2. We've got 50 plus 48 with an offset of 0. And we've got 98. 98 with an offset of 40. Copilot is being annoying. Is that an offset of negative 48? Is that true? So seed 98 is actually, is corresponding to a negative offset of minus 48. So yeah, 98 minus 48. And 98 plus 2 is again with an offset of 0. So I believe this is it. And now we only need to do iter collect. Is that a thing? I think so. Okay. And we don't need that to be mutable, which is very nice. And let's test that. And it says that required collect. So this is integer. Vec. Okay, so how can we initialize a B-tree map as an not mutably? B-tree map initialize from sequence. Is there like a very nice way to collect into it? I don't see that. So let's just insert all of these apparently. So this is just a B-tree map. Ooh, from iter. Ooh, that's very nice. Okay, so yeah, this is now our vector. We don't need to do any of that. And that's not the right thing. Trying to compile this is the right thing. And now we've got everything almost correct. we are offset by a very small thing. Yeah, so we've got an off by 1 error somewhere. And that is because I did this and I don't need to because we are already off by 1. Okay, so I was apparently completely off by 1, not in the right direction. So let's look at that. So our left and right things aren't correct. Okay, so 50 to 2, 98 to 0. Okay. So when we do this, we need to -1 this. Okay. And that would dedupe like the edges, basically. Is that true? Let's think about that. So we need to somehow override these. Pum, 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 pum. So these ranges must never overlap. So we should have 4 keys. Let's actually look at our keys. We've got 50, 50 plus 48. We've got 98 and something. Okay, so that should be -1. Okay, so it's 48 minus 1. And also here, that should be -1. And that means that also here we should say -1. Okay. Okay, so our map is now corresponding to whatever we expect things to be, which means now we need to test our lookup. So, I mean, we could parse and like extract on a big table of all of these, but this is already quite good. Like I'm very happy with this solution of like doing this with the lower bound search. So we've got our category map. We need to basically parse the full structure of our game now, which is we do have a struct of all of these maps. So let's actually just, so our struct is now mapping between a few things. So our full state is going to be seeds, which is a vector of U32s, and we've got a few category maps. So we've got, I mean, we could already make this generic because they are going to add a few categories and we would want that to be generic, right? So we do need something like category maps. Should we do that? No, let's hard code this crap. I mean, this is just they are going. This is going to bite me in the ass, but so be it. Okay, so we've got seed to soil. That's going to be our B-tree map, and that's going to be soil to what it was. So we've got this full thing. Okay, so we do want that anyway in our tests, so can just have that here. So let cool. Can we have that as a const? Is that a thing? Let s be this thing. No, okay, that's impossible. Which I guess like unbound variables is like not cool, basically. Globals are not cool. So let's just add a test that doesn't work, which is test part 1, which gives us okay, so we've got our input let put be this. Okay, this is exactly the thing, and we can say dot run dot input unwrap part 1 gives us currently an empty string, which is actually going to pass, which is okay. So we've got seed to soil, soil to fertilizer. So let's hope Copilot is fertilizer. And fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. Okay, so this is all of our traversal things that we need to traverse through. And it's quite ugly, but we will let that be for now. So let's actually pass this state. I mean, I don't want to compute all of that. Just in order for this to work, I just want to pass one map completely. So let's just do that. So how do we pass the full maps? Fn pass all maps is going to accept an input. Actually, that's just going to be pass state. And that's going to accept an input, which is a ref string. And that's going to give us an iResult of ref dir and state. And we have no. We know better than that. So pass state is we are going to map a lot of crap here. So we've got our tuple of pass seeds preceded by no. So that's going to be basically anything that's actually okay. Okay, so we might actually not care about like the intermediate levels for now. Because we are basically now mapping only from seed to location. So we can have a list of B-tree maps. So let's just have that. Okay, I think that would be very nice, much nicer. So we've got vector, we've got uh, translation maps. Translation maps, that's going to be a vector of B-tree maps. Because we don't care about the actual things in between. So we just need to, okay, so translation maps. We just have our start position basically. And then we could actually like formalize this translation between two maps, regardless of like whatever the thing that was before. So we've got our translation maps, which means that we can also pass them separately, which would make our lives a little bit cleaner. So pass maps, or just maps then. So how would we do that? So firstly, we can test that out with only these two. That's enough to test our actual thing. So that's going to be another test, which is test maps, and our input is going to be exactly this. We can say that, and that is going to be a vector of two things. I'm an asshole if Copilot actually succeeded in understanding the pattern here and actually completed this one correctly. We will actually test that out in a minute. We will actually write the code first and then see that if it fails, and we will see that obviously this does not make sense. But surely, yeah, something will happen. I mean, it might be. It might be. Minus 15. Is that true? 52 minus 37? That's 15. Wait. Both of these are in the same direction, but one of them is negative, one of them is positive. I'm actually not sure if Copilot succeeded, but it might have. So yeah, let's do our passing thing. So we've got a separated list, separated pair of not separated, yeah, separated, not pair, list. One of, first of all, it's going to be preceded, so preceded between with any character that's not in white space. It's just going to be words. So ASCII, not ASCII. Char, not any char. We want like A to Z basically. So there's a thing for that. So A to Z, we'll find that in a minute. So it's preceded by that, and then it says, well, we already passed the map out of that, so you know what? We might not even need the whole like map within the previous function. So we could say we could like remove the map from this, but whatever. So we got category map basically. So we got preceded by something and category map, and that's a separated list of that. So that is going to be just a vec of the tree map of type U32 to I32. And in order for this to actually be correct, we only need to do, you don't need to do anything fancy because it's already collected into a separated list. So that should just do the trick. And in order for this to work, we need anything fancier? No. So let's just, wait, why is it unhappy? It says this function takes 2 parameter, but 1 was supplied. So separated list, oh, I see. So going to be a category map split by this thing. So don't need the preceded thing. Okay, and A to Z. So Fn A to Z. That's not correct at all. So num definitely has like an ASCII thing or something. Letters, not in complete, it's somewhere else. Where could it be? Combinator, complete, new line, character. So could be around like the digit area. Just because it's like not digit, but yeah, we've got alpha. Okay, alpha 1. Oh, but it's alpha plus dashes. So non-white space. Is there like a non-white space thing basically? So we've got that's going to be map name, which we don't care about at this point. And we can say something like not digit 1. Let's see if we've got not line ending, not white space, space. Ooh. So we could say, yeah, space something. That's very nice, but not exactly what we want. I want like all the things that are not white space, basically. Yeah, that's going to be digits. That's alphanumeric is close, but I want also like dashes because we do have dashes now. Or we could like do a tab, new line, line ending, not line ending, one of. Okay, so we could say one of tag this thing and okay. Okay, so not tag base, and this is going to be our and we need to map that because we not map, we need the many one on that. So not space, many1, input. Input. That's going to give us a string. And it says vector. So that's not good. We want something else. So do we want to just like do this thing where we say we don't care about anything? We could say that. So we've got our separated list of categories, which is going to be I don't care, and I don't care is going to be let's think about that. So we just need actually not tag colon. Or so this one is okay. So this not thing is not the not what I think it is. So is not. Okay, so that's the one, and we do need to say many1 not colon, and that thing is passed here. And it says that many1 is okay. So sorry, not many1, but map res. Are we missing something? No. So not this thing. So we do need many, but we don't want to collect that into a vector. We just need to like advance the input basically. So many till. That's going to okay. So oh, many till sounds like amazing. So many till will tag this thing. And it says that expected I result still stir error and got found vec. Why is this collecting into a vector? That's very, very annoying. I feel like does Rust have a type alias? A renaming vec b-tree map sounds like a very useful feature. So probably Rust has that, but we are not going to like do that now. But probably yes, like probably also my ID can say like unallied lifetimes, show expanded macro. We could like probably say something like type. Is that a thing? Let's just vec b-tree map u32 i32. Seems like it would work. Like this red squiggly is actually not it's not real. So yeah, seems like it might be actually a thing. So we could say like VM for like vector or VBM for like vector b-tree map, and like we could make our lives a little bit shorter when we actually write a lot of stuff. And then we can also like change all of that in like a very simple like in one like in one place basically. For now, I'm just going to be a code monkey and just write that easily, directly. But that's actually like a very nice feature that I might use later. Why am I like having a hard time with just consuming this, which are things with which I don't care about? We've got a separated list, and we just want to say something like repeated. sequence of something. Sequence? So we don't have a sequence. So this is going to be a separate list of how do we actually pass, like, let's go with for day 4, I think, maybe in day 2, I think I might have. Okay, let's go for day 2. And part 2, let's see if we've got, like, okay, so here I passed that directly, which is not ideal, but we could do that. Alpha. Okay, so I said alpha 1 to actually pass things out of the thing. Okay, so alpha 1 then. Sure, whatever. So we've got a tuple of alpha 1 and then not a space but a dash. Yeah, so we've got tag dash, then another alpha 1, alpha 1, then what's the structure? So we've got, oh, so we've got 2 and then another name. So instead of all of this crap, where is it? Okay, so we've got 2, then another alpha 1, and then tag space. Yeah, so this is our I don't care thing, which we could say, we could map that into we don't care at this point. And we can change that later if we'd want to. We could, you know what, let's actually just save that information just because we can. So struct and we've got map name, and that's going to have from thing to thing. I'm not sure why does Copilot actually like completes here this thing with lifetimes. Maybe because it's a ref string and it has to like know the lifetime of things. I'm not sure. You know what? That's not going to work. We are going to have that as an actual string, and we are going to clone things because I don't want to think about lifetimes at this point. String. So yeah, no lifetime specifier. And this is the map names. And thing we are going to map that into this thing. So, oh, we could say dot map instead of like the whole like wrapping the things with map ourselves. So, oh, but that's ugly because it needs to like actually wrap the result, which I don't appreciate that much. So let's actually do this correctly. So that's going to be our from to, and it's unhappy because it's a ref and we are not returning a ref, we're actually returning the object. Okay, so for now we don't care about this. So we are separated by map names. And let's actually test maps. So test maps. Let's run that test. And now we are back into our assertion. Well, I said, what is this? We are back to the place where I asserted type annotation needed. Alpha TE. No, no type annotations, please. I don't care. I don't want type annotations. Cannot infer type parameter T declared on function 1. So let's actually infer that for everyone, and that's going to be refster, refster, refster. Okay. Is it now happy? And it says that can't compare. Okay, that's very good because we haven't like actually looked at the assertion that Copilot has made for us, which is to say state is not comparable because we are not deriving from debug or partial quality. And what else? It says no implementation for vec collection of B-tree map against state. And that is correct because we are not doing this whole thing. We are going to only assert, yeah, this is our assertion. And it says that we are stupid. Okay. No colons here. And let's move on. And our assertion is now, it's now saying, says error value, panicked. Okay, panicking is good. That means we've got an error, which means that our parsing is still not working as we expect it to. So test maps. Are we using maps? We are. So let's look at the actual code that what we're testing against. We are saying seed to soil, then space. Are we taking the space? I hope we are. Yeah, okay, so we are passing all of that. Let's actually test that quickly, just like in an isolated thing. So fn test names. We don't care about them, but we need them to work. So this needs to leave us with map colon. And we are missing the test macro. Okay, and it says that we are missing partial equality. So partial equality then. Okay, so our name parser is sort of working. We are left with whatever it is that's like map and whatnot. And that means we are panicking somewhere else. Or you know what? It might be actually, I know what could be, which is we are missing an optional new line right here. And we are missing it also here, which is a thing we don't care about. And we are also missing another thing here, which is another thing we don't care about. And it says that found signature, blah, 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 blah. Type mismatch closure arguments. Oh, yeah, so this thing, we literally don't care about its type. Ooh, and our test names is still passing. That's not surprising or anything new, but let's actually now test our parser. And it is still panicking on something. And it says error, input, all of this crap, and it says code tag. Which tag though? Because we have a tag that is unhappy right now. We've got 1, 2, blah, blah, alpha thing, and then map. So where's our tag that's actually failing? Map names is used here. And it's also used in our actual separated list with our separator, which is our map names, and we've got our actual category map. So let's look at this one. So this is preceded by a tag of map \n. Then we've got our terminated category with an optional new line. Do we need anything else here? Like, I don't know. It might be preceded with also with an optional tag space that we somehow missed. I don't know. And our category itself only has like this thing, which we know passes well. Let's try that. And if it still panics, then we'll try to Okay, so first of all, I see. So we're still like we still see seed to soil, which means our input is actually failing earlier. So that is not in the category map code at all. Is in the map names. So we still have this thing, and it says alpha and then tag. So why is it not working? Oh, I see, because it's not a separated list. It's preceded by the map name, and then it's separated by just new lines. So it's preceded by map names, and that's going to be on separated list between new line and input goes here. And we've got failing assertions, which are better than panicking. That's very, very, uh, that makes me very happy. Type alias VBM not used. Well, let's delete that then. And by the way, I don't know if you will enjoy that, but I do have like a key capture, which you apparently, I don't know if you can see that or not, but let's just turn it on and it might be useful. I don't know. Yeah, okay, awesome. So you are seeing the key capture. Okay, back to actually debugging. So we've got our assertion. Let's actually make sure that it is actually correct. So we've got our first map, which we know to be correct because we have tested against that. And let's actually look that maybe the order got flipped. So we've got, first of all, okay, so our left side, which is our actual, only has exactly, has only one map, and it is exactly the same as the first one. So that means we are just not passing the two maps right now. And we're still not sure that this is actually correct because Copilot has completed that for us, and I'm like for fun keeping it in. But we do need to basically have that working. So let's figure this out then. So we've got our map names, not map names, sorry. We passed our maps and it is preceded by our map names. And also the map names itself is preceded by an optional new line. So let's just do that. So, oh, but we did that already. So maybe first of all, let's not do that as a tuple, but actually this is like so terribly bad, this whole thing. So let's do preceded by opt new line. It might be even two new lines, I'm not sure. We'll actually need to do to like make sure of that. And instead of like this whole like terrible tuple thing, let's actually do separated pair of well, that's going to be alpha, then tag 2, and then another alpha. And the alpha is going to be terminated with so that is going to be terminated. Is there a way for like bracketed from both sides instead of like preceded and terminated? Probably there is, right? We've got terminated and we've got separated pair. That's a separation in the middle. We've got delimited. Delimited. Ooh, that's very nice. That's good to know that we've got like a delimited way of like doing this. Is that yeah, first, second. So and we are only getting let's see 0321 and we are getting only yeah, so delimited. Only the middle. Matches an object from the first parser and discards it. And then gets the object in second parser and fast. Okay, so yeah, so delimited is our thing. And we can say optional new line and then definitely a tag of space. And this will give us a very cleaner way to actually map things. So all of that, comma, and we've got, instead of all of this crap, we just get from and to, I should hope. Yeah, that's very, very nice. That's much nicer. And that is cleaner, and still we don't know where our bug lies, but we will find that in a minute. It says type annotation needed, so let's add our type annotation. Okay. I mean, let Copilot add the type annotations. I'm not claiming to actually do all the dirty work, just be thinking about the algorithm. So instead of all of this crap, we need to find out why are we not parsing the thing, which I believe might be because we've got more than one new line. So let's actually do, can we say like new line twice, basically? Like optional new lines. So we can say many one. But many one is not good because we are going to, might be, okay, so let's actually do, okay, because we are discarding it, we don't care about the type. And that still hasn't worked. So we are still not passing. So let's look at that closely. Not map names. Okay, so we've got preceded map names. Oh, because maps isn't actually like doing the maps. It's actually only doing one map, which obviously isn't the thing. Okay, so we have two things that we need to basically fold into this. So this is going to be it is going to be a separated list of vec B-tree map. So let's write it out a little bit. Okay, so we've got separated list of preceded, first of all, optional new line because we don't know how many we've got of them. And then it's going to be map names. That's correct. And we are going to create this category map. And this category map is by itself is folding many lines. And is this the thing where like everything works? No. This is now panicking and it says seed to soil isn't working. First of all, so let's do this. So we've got a separated list indeed by map names. And it says many one not imported. So that's not good. You know what? This is actually separated only by a new line, basically. And this is actually a category map preceded by map names. That like maybe a better way to model this? Ooh, yes, it is the better way to model this. And also we've got our things working and now we can actually debug the assertion which Copilot generated and I claimed to be completely false and I put my dignity on that. So let's actually think about this soil to fertilizer map and let's actually figure out where does Copilot actually went wrong. So we are mapping between, firstly, this is our source, this is our destination. And if we look at the structure of the map, we say that the structure is basically was our was our structure. So yeah, this is basically we need to map between source to some like between if this map is the seed to soil, yeah, we map between this one into this one. That's why this is the ranges that we need to map from and to, and this is our offset basically. So and we need to compute like the offset, and we need to also end the ranges. So from iter, let's look at that. So we should go from, yeah, definitely. I'm just gonna not like actually let's just actually reason about this on our own. So we need to map between 15 and our offset is going to be 37. And so yeah, that's going to be, oh, sorry, we are mapping, yeah, we are mapping between 15 to minus 15 because we are starting at 15 and our range, and like this is our offset basically. Yeah, so between 15 to minus 15, and we do need our, yeah, plus 37 minus 1 and mapping to 0. And now Copilot will get the idea because, well, we are trying to tell it, or maybe it doesn't. So that's going to be 52 mapping to whatever this offset is, which is 52 minus 37, that's 15. So that's going to be minus 15 now. Again, apparently. Yeah, that's the same offset, okay. And we are going to map the next one, which is 15 plus 2 minus 1 to 0. That's okay. That's actually correct. And next up is going to be 0 to 39. Offset of 39 plus 39. And 0 plus 15 to minus 1. Yeah. And that's an offset 0. So this is the map that I claim should be correct. And our parser actually agrees with us. So at least my test and my logic are consistent with each other. Which means that we do have everything we needed to build up the full game map. So let's just collect everything to us to the state object. So we've got our state object, which only has the seeds and the translation maps, and we've got fn parse state, which accepts an input string reference, and it's unhappy because it's a colon, and we are going to be parsing this as, well, yeah, going to return an iResult of stir state, and definitely not like that because we know better. We are going to say a tuple of what are the things we care about and what are the things that we don't care about. So it might be preceded by an optional new line because, well, we know that. Optional new line, that's always like there. Then instead of parse numbers, we do have parse seeds, right? We already wrote that thing. So that is going to be the thing that we aim for. By the way, is this seeds with capital? No, it's not a seed with capital. Oh, that could have been very, very, that could have made me very unhappy. So parse seeds, which also would obviously break now because we've added a test for that. So we should probably also find the case insensitive way to match, but that comes later. So we've got parse seeds, and we could just call that seeds then. And we've got not only that, but also the maps. And we need to map that into our thing, which means that we do this, say this thing, and we pass the input, and it claims that it doesn't know what seeds are. Interesting. Why doesn't it know? I think it should know. I think this is basically just my ID complaining, not the actual compiler. So test maps is not the thing that we wanted to test. We want to test the state. So how do we test the state in a clean way? We write another test, of course. So let's write another test, which is test fn test state. And state is going to be very small because I really don't want to like debug the whole assertion again. So we can just add these two together. And also let's add 2 new lines just for good measure and see if the compiler breaks. So we've got that. Say let input be this thing, close the thing, and we can say let expect, and that should be, I think, it, because it's now copying everything, and I don't need to like. If there's something that I know about LLMs, that they are predictable in like copying shit, and that should be okay. We just need to run the actual test. So let's run that, and working. That's very, very. That makes me very happy. The overall, the overlay shows the command keys. Wait, what? You press on not moving. Fn new line backspace shift. So I'm not sure. What are you saying? Is it like not working for some reason? The overlay shows command keys that you press, but nothing alphanumeric. Are you sure? Because I think like when I'm typing this actually shows it. I can see it in the stream. Um, I'm pretty sure the overlay showed that. If it doesn't, let's refresh the screen capture for a minute. So let's debug that. Thank you, by the way, for like letting me know that things aren't working. Okay, so I've refreshed the screen capture, which means that now everything that I press should be a little bit better. And I've also done like a transition. Okay, I'm not typing that much, so that might just be it. By the way, it works both times. It worked both times. You were looking, but not when. But when you're not. Okay, classic computer problem. Awesome. Okay. Um, that's very like I like that you actually like keep me on my toes. So yeah, we've got everything that we need like in terms of actual parsing logic. Let's actually try to run this thing, right? So we've got let state the parse state on input. Let's rename state input back into like a proper thing. And we can just literally say, first of all, input thing and state. And let's just assert that input is empty, that we've consumed everything. And that would actually be the first test. Just let's see that it actually works. And it says expected one of found hash. And that's because I left an SDF grab thing here. And now we're saying, let's see, input escapes function body here must outlive. Um, wait, let's say okay, or can we like I want to basically convert that into an anyhow error instead of a passing error. So can we say like expect failed to pass state. Okay, good enough. Okay, so first of all, our assertion is working, which is very good. And now let's actually debug our state. So we need to collect the, okay, so let's part one solution. Okay, so we need let minimal number minimal seed. What is it? What are we looking for exactly? We are looking for, that's actually, what is the lowest location number? So location is the latest, is the last one in the translation. So we need to basically, okay, so let's translate everything. So let translated be state dot translation maps dot iter. So for each of the translation maps, which are ordered in the correct way, because they are we are seeding from, we are looking at everything from one thing to the other. What are we trying to do? We need to map everything. So let's actually write our mapping function outside of this the scope of this run function, because this is actually going to be a little bit tricky. So we've got our B tree map, which we have one which is like, we have one that's actually like valid. And let's test our translation. So test translation. Oh my God, writing tests in Rust is so nice. You can do that in the same path of your code, and like everything is talking to you and being nice to you. Okay, so we've got our B-tree map and it looks okay. And we can assert some translation things. So okay, let seeds be a vector of all of these. Yeah. So this is like the actual vector, right? We look at, yeah, 79, 14, 55, 13. And after one round of translation, they should map into something. So how does translation work? Yeah, that's not a thing. So let's actually write our translation function. So first of all, to do, just so we'll know that this packs. Okay, awesome. So fn translate, which accepts seeds, which are a reference of U32, and gives us back another vector. Okay, that is, I mean, actually, you know what? Let's actually do that like in a way of like one seed every time. So we've got our map. So that's going to be a borrow of a map. That's okay. And we've got our seed, which is just a U32. And that's going to be give us back a U32 as well. So translation map, that's going to be just one map for now. Then we are going to actually like apply that for all of the seeds. So how does that work? So let's think about it. So we said that the map, let's just call that map now, has a function called lower bound. And if it's not here, that's because we are, this should be lower bound. This is behind an unstable feature. So how do we use this feature? is there a way to like do this cleanly without? I mean, we could like iterate on our own, but like using lower bound is nice. Size hint, inline lower bound. It says unstable. Yeah, so let's, how do we use this feature? So we need to probably say something, right? Uh, Rust how to use unstable feature. And pass dash z minus blah 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 blah. Use of unstable. Okay, feature collections. And it says that trait level attribute should be in the root module. Okay, so root, this isn't that the root module? Anyhow, let's look at that now again. Where's our translation thing going? And it says still that add B-tree cursor. Okay, so I've added that, and we can we now like use map.lower bound? And lower bound accepts a ref to self and a bound. Interesting. So what's a bound thing? Okay, so we say included, excluded, unbounded. So an infinite endpoint. So indicates that there is no bound in this direction. Interesting. So let's look at actual usage of that. So we say we insert 358, and we can say for e value and map.range excluded 3, included 8. So that's iterating over the range. No, that's not the thing that we want. We want, let's look at the actual usage of lower bound. So lower bound, sorry. We insert 1, 2, 3, 4 to this, and we say lower bound included ref2. That's going to give us 2. Okay, so we say, okay, this is exactly the thing that we aim for. So we say that. So, okay, we are just using the convert to method call. And why is it always returning 0? Because we're not giving it anything. So that's going to be now bound included seed. And that gives us a usize, which, what? Why is it giving us a usize? Isn't that supposed to give us something else? If we look at the docs, it says that, wait, is that's a cursor. That gives us a cursor. Cursor ops bound. Okay, we need to copy that as is. Okay, so that's going to be let cursor be this thing. Why is it claiming that this is not working? If we convert that into B-tree map thing, does it? Okay, that gives us the cursor. Okay, that's very good. Now we can say ref seed. And that gives us a cursor, which and that like the types are still unknown. Cursor type AV. Edge next. Okay, so can we type that? Let's type that. So our cursor is going to be from U32 to I32, maybe? That the thing? Takes one generic argument. Oh, so it's only the value. Right? It gives us, oh no, it's the cursor is a key type. So that's going to be a U32. And let's find the actual. By the way, can we just look up for the closest one without like actually doing the lower bound? Let's just do that. So we've got our map. Closest basically. Node find, try find, predicate no, that's good enough. Wait, why is this like crazy thing? So we've got first key value. No, that's not good. Last key value. That lower bound. Is it now working? Was it like broken for wrong reasons? The method call? Yeah, okay, so it's now understanding that this is a cursor. And it says, okay, it knows more things than before. So what are the methods of a cursor? So first of all, let's look at the actual use of this cursor. So it's some key, basically. Given that it's above. Okay, so passing unbounded will return a cursor pointing to the first element of the map. Wait, if no such element exists, wait, okay. Returns a cursor pointing to the first element that is above a given bound. So we need an upper bound because we are giving it the bound. We need the. Let's think about that. Let's think about it visually because I need to think about it visually. Okay, so we've got our trusty friend Excalibur. We've got a B tree. So let's look at the B tree. We've got some keys, which I'm not sure how exactly is this balanced, but not I don't really care. And I don't think is a B tree actually like a binary tree? B tree. It's a self-balancing tree that has more than it can have more than one thing, but that doesn't matter so much because it's just it is still a self-balancing tree. Okay, so basically we've got a tree, and we have, let's claim that this is 1 and this is 3 or something, and we've got our query is going to be 2. So we will land in our binary search here. And what we would want is we need to know we need and like this one has an offset of okay, so this one is pointing to like a plus whatever offset. And we do want that offset because this offset applies to basically all of this range. So we need the and we are giving ourselves as the bound. So we are the upper bound for this range. Okay, so we need to say bound, so not lower bound, but upper bound. So we are looking for the upper bound given our self and we include our own key within that thing. So let's look at that just now with the actual test. So we say we are looking for 3 and we say included, we get sum 3. That's very good. And if we say excluded, we don't care about that, but that's going to give us the key below us. So excluded basically means, yeah, okay, so we are the upper bound all the time. And just to like make our sanity be make our sanity be somewhat reasonable, we could say one more thing, which is to say we could insert to all of our maps the key 0 with an offset of 0 before everything is actually happening. But we'll see if we need that because we can just use that. Okay, so we say now, okay, so if let some key be cursor, oh, we could, can we just say, yeah, get key, just like that, right? Is that a thing? And it says that we are expecting, okay, so we are mapping that into, okay, so we can literally just do this. Okay, so if we found something that we are using it, otherwise we are basically mapping to 0. Okay, so match cursor, and we don't need to actually do anything. We can just literally do this. I think this is a translation basically. So we basically say we do the lookup, and then we either return something that's within the range or we return a 0 offset. Okay, so I think we can now test that. So test translate. So first of all, that's not our expected, that's going to be our map. And map iter literally map translate collect into a vec of u32s. That's very good. And that's going to be let actual be this. We don't need to tell it what to collect. It will be okay. And we can say assert equal vec expected, and that is definitely not the thing. That's our actual, that's our translated. And our translation map us to, let's go back to the actual test value that we've got, which is to say it corresponds to soil 81, 14, 57, 13. So 81, 14, 57, 13. And it says cursor current. This expression has cursor U32, I32 mismatched types. So was that not like the way they did that? Or have I missed something in the docs? Let's look at that. So it says cursor.key. Okay, so cursor. Okay, so we could actually just use cursor.value. Cursor.value, and that's an option. So that's going to be all or some seed and unwrap. No plus whatever, yeah, just that. And we need seed as, wait, why is it unhappy? Because we expected that to be an option of, well, it's an interesting. So this is an offset. We need to say, ooh, I see. Okay, so let's just do that. So match on cursor value, which is our offset. And if it's some offset, then we need to say, okay, this is just seed. And this is going to be plus that offset. And it claims that our offset is okay. No. Casting ref I32 to U32 is invalid. And what can I say about that? Can I say in borrow to owned, but we cannot, we need to bring it back, give it back, right? Or it will probably fail. Said okay, so this map needs to, oh, I see, we haven't iterated on this correctly. Oh, shit, that's not the thing. We need to iterate over the seeds. And we need to translate that. And in order for us to translate that, we need to say seed and translate map. Like translate on map. And why is it unhappy? Because it said expected U32 found ref I32. So why is this U32? Okay, that's better. And it says that it was, yeah, okay. Change to ref. Yeah, okay, we need to borrow everything. By the way, this can also be borrowed. We don't need a copy. So let's just copy that. Let's pass that right that, like so. And here, do we need anything fancy now? We don't need, right? That ref seed or star seed. By the way, can we just cast that as 32? No, that's, we're not gonna have nice things. So seed plus offset as I32. Okay. Seems to be somewhat sane. And mismatched types. So this is ref of U32. So as ref of, yeah, that's okay. Actually, that's very good. And that is as I32. Yeah, as U32. And casting this thing is invalid. But that is not. This is found to be type U32, expected ref. Flyfix. Okay, so odd actual. Oh no, come on. That's it. That's a VAC of U32s. You should know that, compiler. Oh my god, this translation works. Okay, so now that we've got that, we can actually translate all of the seeds and then find the minimal one. So we've got our state, we've got our seeds, which are just, well, we just say state dot seeds, and we map over them. And so for each seed, we need to apply the map. Okay. No folding. What is this crap? Oh, by the way, can we destructure this? Because I want to split basically the thing. So let seeds comma maps, translation maps be, yeah, all of that, because I want them to be separate. So state is no longer a thing. So seeds map, probably iter map. So we got seed, translation, and we want to translate all of that. So for each seed, we are going to iterate over all of the maps, or would we like to actually do that the other way around? What would be faster? Keeping the map in memory would be faster because of cache locality. So let's do that translation the other way around, which is to say, we want to iterate over the maps, and for each map, we can. Interesting. Doesn't really matter, actually. You know what? We're optimizing for speed too early. So we are translating, yeah, so seed instead of translate, we want to say translation maps. And we want to apply translate map seed. Okay. And that's going to be, and we want to take the minimum of that. And that's going to be lowest location. That's an optional map. Why is it an optional map? Because we are not returning the seed. Or are we? Wait. So this is so let's just look at that for a minute. So we've got seeds. For each seed, lowest location. So for each seed, what we're doing is we are translating it iteratively, right? No, that's not what's happening. We are not folding this. So that should be iter fold. Yeah. And that is going to give us well, U32 is that. So let's look at that. We've got map seed. Why is this not known? This is a vec of U32s. Let's unpack that with the type int. So we've got that. And now let's continue with unpacking everything. So this is seeds. That's a U32. And our translation map, for each one of them, we are passing in the seed, we are applying the thing, and okay, I think that should do it. Not sure like how the performance is going to be, but we'll definitely give that a try. So test part 1 should give us, well, what's result? 35. So let's run the part 1 test, and it says that it cannot compile because we have mismatching types. So let's divide that correctly. And it says U32 cannot be dereferenced, and we don't need to dereference that. And that needs to be a ref. Then it will say that we need to dereference that. Then it says the question mark cannot be applied to type C. So let's not do question mark. Let's unwrap and hope for the best. Or do we need to unwrap that? We are mapping over that. That's a map of iter. No. So we've got our seed. And we are trying to apply. First of all, we don't need any of the, like, we don't need this thing, right? By the way, probably like having the intermediate layers would be useful later, but okay, so we've got that. We are translating. Why is it unhappy? It says this is a map. Why is it a map of cell? Oh, it's a map object, not a hash map object. Okay, that's okay. So what is this? This is right now we are folding all of that. So that should be something, right? Like what is this and what? Wait, okay, so mismatch types. Let's just do that. So that's going to be seeds.ita dot all of that, and expects a found option u32. Oh, that's nice. Okay, so I'm okay with option u32 for now. And I mean, there it is. It's not an option anymore. And it says the question mark operator can only be used on results, not options. So if it's a result and not an option, then yeah, let's just unwrap. I don't care about that. And now let's actually run the test, which is this one. Okay, it's panicked. Attempt to add with overflow. Ooh. Pum pum pum. So, where's our panic happening? Panic at the Disco. So let's debug. I mean, we could cast everything to a higher what's it called? To a higher god damn it. Precision. Wait, why does it have an overflow? I mean, we have not done anything fancy. Oh, it might be negative numbers. Interesting. How is it getting negative numbers though? Okay, so first of all, let's actually debug the seed. And let's just call that index. I mean, I hate the name seed. Okay, so we've got our index and we do have our cursor. Let's debug those and we will probably see that we need to borrow, of course. Always borrow things, never do anything otherwise. Okay, so we've got cursor, which is, okay, our index is 71 and our cursor it is some key with a value of 25 and then offset of -7. So our index plus an offset should be correct. And it's unhappy because it should be actually an I32. So our offset is an I32. And all of this calculation should end up as an okay, so offset is already an I32. We don't need to do anything fancy. Yeah, okay, so now we've solved the panicking stuff. Yeah, we are basically asserting that this is always positive, like the index plus offset is always positive. We're never out of range. Okay, so that's done. By the way, now we can see that we've got, let's find our 81 in the log. So 81, and now we survive that. Basically, we say 81 minus 7, we get 74. So 81 minus 7, we get 74. Yeah, indeed. And our key is 71 because the next up in the map is probably a lot higher than that. Anyhow, yeah, our debugging skills get a little better every time. Okay, let's actually continue. So we get 4. And why is that? So this is where actually printing out the intermediate maps would be nicer, which means that I would transpose the operation just because we want our intermediate results and then take the minimum over the last result. So let's fold everything. Like let's do this from the okay, from okay. So let layers be translation maps. Iter over thing. Actually, how can we get all these like intermediate maps? We would want like to offset every like because okay, so we do want to well fold, but we want to do that for the whole vector every time. So we have a vector and we want to apply that function that translates to like every layer. Let's think about that. So actually we could like instead of like taking the minimum, we could literally save all the layers. Can we, right? We can. How can we save the fold? I mean, I don't want fold, I want to like carry everything. So let's see if we've got another method that might do that for us. Not reduce, I want all the intermediate steps. So filter, map, enumerate for each. Into trifold, fold, chain, reduce, split, take. So advance by any how kind array chunks as ref, borrow by ref, call once. Okay, so let's look this up. So Rust fold all intermediate steps. So that's going to be iter scan. Ooh, that's nice. Okay, so iter.scan. Then we've got well, we need to pass it the seed, which is the next thing, and then that will give us not the minimum. So we can collect that. So let's collect that vector. Going to be that's going to be all layers. So for each seed, we've got now all the intermediate steps, right? Let's see that we are actually using this. So we've got our accumulator. Then we need to return our translation, which is our accumulator, basically. Are we getting the accumulator? Wait, what? Mutable. Ooh, okay, so we are doing the translation, and then we need to we need to say yeah, so that's going to be our that's going to be our index, and our index is going to be something. And we have to assert this as actually working. Why is this returning an option? This is not an option. This is just a translation thing. So do we need to say anything fancy to in order to make assert to make this work? We need to borrow it here or something. And now that it says expected thing, found thing. So we need to point in. We don't want to borrow because it's already borrowed. We do have our mutable index. Immutable? Yeah, we do. Right? We don't. Interesting. So it's already mutable, like a mutable reference. Okay. Let the compiler guide us instead of okay. Okay, it says lowest location to string. Let's return that into something empty because we don't solve that. We haven't solved that yet. And it says scan index something. Okay. What else? Closing delimiter. Mismatched closing delimiter. Wait, what? Okay. Syntax error. Okay, shit. Um, let's look at that. Okay, so we are definitely we don't have enough parentheses. Okay, so we do need this one, and we are missing one more parens. Okay. And it says layers must be given an explicit type, which I totally get because, well, that's going to be vec of a vector of vectors of U32s. And we need to collect that in order for this to work. So we need to collect. And it says that cannot collect value. Wait, what? A value of vec U32 cannot be built from an iterator over an element of type nothing. Why is that? Because we are doing this. So they claim this collection is not actually working. So we need to return this. Okay, so let's do that like this, like so. So this is our assignment of updating the thing. And then that what they want. And it says some index. So some index. And it says cannot be built over iterator of mute thing. So how do we make this not mutable then? I mean, I could literally clone everything. Even that won't work because it says ref mute. Oh, it's the reference, not the mutable thing. So that's going to be now like so. And it says cannot be dereferenced. And it says found blah 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 blah. I fix. Can I just clone this every time? Like, why? What's all the fuss? Let's just do something. Okay. So first of all, everything runs, which is surprising to say the least. Then let's actually debug our layers. So let's just dbg them. And let's try to look at them. So we've got our first seed is translated through 8179. Hey Katya. Nice, nice to see you here. Wow, that's very, very fun to see. Like, love people like and on stream. Um, welcome. Um, okay, so we are trying to figure out if this translation is actually working. So let's trickle down this thing and see if it's actually making sense. So first of all, if we go to back to like the assertion of how would everything need to work? So it would go from 79 to 81 to, yeah, okay. So, and then it needs to end up at 82, and it's ending up at 83. Ooh. So 81 is the first one, which is okay because we are starting with 79 and then we don't see that in the layer. We could add, let's actually add that so we'll have our starting state as well. So if we go back to our starting seed, zip that like easily, it would be a little bit of a hassle because it's like older than an. Actually, we could try. So, or you know what? I think we could literally. So we've got that. How can we do that? I just want like the first one to basically be an empty map. Okay, if we hand over another empty map, then we would be okay. So we've got our translation maps. So let translation maps be translation maps. Spec of translation maps. Can we chain like easily things? Would probably, right? So so let's just create a vector of new so the tree map new. Then this one we chain it with all of that. Basically, chaining an empty map would allow us to also see the first element easily. And probably do this in a cleaner way, but it dot iter dot chain. Yeah, iter collect into. Yeah, we don't need to actually iterate over this to make this work, right? Yeah, should be okay. Oh, and dot collect over the end. Okay, so we've got a vector of B tree map. And let's just assert this is actually the type by saying this is a vec of B tree map of U32s. And it says that takes at least 2 generic arguments. Well, yeah, pointing to I32s. And now our translation map has one more layer, which means our first layer is going to be, wait, what? Ita, do we need to, can't we just do this? Never mind. Okay, no debugging for us. No debug values. I don't care about that. That's not important enough. Okay, so we've got 71, 81, 79, 79, 72. So let's look at that. So it should have been, yeah, 81, 81, 81 again. So that's not good. That's not good at all. So for some reason, the first thing that happens is that it's getting offset by 2 when it shouldn't be, which means our translation logic isn't working as we expect it to work. So let's debug our map again then. So we've got the of index and cursor value, which is the offset. Okay. And let's look at that. So we've got 79. Why is 79 the first thing? Unused variable expected. What? What is this? Oh shit, we haven't tested it out. I thought that actually worked and we haven't run the tests. That's not good at all. Okay, it is working, but okay, that was apparently a fuck up of a fuck up on my side. So let's test that. Okay, so we've got the value 71, 79. So how come the first thing we see is 79? Yeah, okay, because we're starting at 79. Okay, that's very good. And we are seeing offset 2. And that is not correct because 79 shouldn't have an offset 2. It should have an offset of, let's see, offset of 0. Wait. So 50 plus 48 is above 79. So it should have an offset of -2. This is what I'm reading from this layer. So my interpretation, this actually works, which means I need to read that again. So we've got 79 should go to soil 81. Means this should have gone +2, not -2. Oh, it is +2. Okay, that's very good. So 79 should go to something. Why is it again 79? It should have been at this point. Okay, so the next call should have been 81 because we should have added everything. So that means our folding logic isn't working. Let's look at the logic. So we've got index some translate thing, and that is just not doing the thing that it's supposed to do. So this is our mutation, and we need to say index equal to this thing, and this is the thing that it's supposed to be equal to, and then we need to actually return our index. And all of that should be wrapped in an expression. And we should borrow or something like clone. Let's clone that. I don't care. And it says we need to borrow. So if we're borrowing, we don't need to clone anything. That's not important. Then it says cannot do this thing because of this thing, and we need to figure this out. So required by this bound collect. So the trait from iterator, ref mute ref u32. So can we do this and then update things? Take this mutably like that. Ref mute. Is that the way? Cannot assign new value to an immutable value more than once. What? Convert to ref mute 32, and then it says cannot assign new value to an so this whole scan thing is quite annoying. Okay, let's try to compile that, and oh, we're back into the same crap. Clone, would that help, please? Map ref. Oh, that's interesting. Maybe this. No, so the other way around. So we need to borrow again. Oh. It says differs in mutability. Oh, interesting. Fix. Temporary value is freed at the end of this statement. So this is a temporary value. And in order for that to stick, we need to do something. So how do we make it stick? By cloning it and letting this thing work. We basically, all we need to say is like, okay, so let index be this thing. Oh, I see, because that's why like mutating everything is like so annoying, because okay, so let result be this thing, and we do need to somehow make this work. And still says borrowed value doesn't live long enough. Oh my god, this is so annoying. So we could literally say let seed be seed clone, and then that's going to be mutable. And that means that basically we know exactly how long the mutable thing lives, because we are yielding everything. Okay, so let result, some result. Oh no. Yeah. So back to assigning to our index and index.clone. Okay, so things are running, which might be working better. Let's actually look at that in a minute. We don't need this clone anymore, probably. And let's look at the code. So we are still in, okay, so we are still seeing the same value every time, which means that we're still not doing this the thing correctly. And if we fold, then, well, that won't help us so much. We do need to understand how fucking scanning works. Because it should have been 79, 81, 81, 81, and instead of that, it's 79 all the time. But somehow, by the way, it somehow still like updates things here on the line, which means we are just yielding away the wrong thing, but we are not, like, the scan isn't working, but the translation does. Okay, so fuck that shit. Let's just fold and see the debug prints. So instead of all of that, we've got our seed, we've got our map, and we are doing this every time. We don't need this mute seed. We do need to pass it in like so. This is a borrow, and we need to pass the borrow in, right? This is, yeah. Oh, we need to borrow the map, definitely, right? Oh, it's already borrowed. So which one is it? Is it like point? Translate. Okay, so apparently ref. And it says that U is not an iterator because, yeah, we're not collecting anymore. Okay, and that is no longer, this is only the seeds. So that's going to be translated. It says there are, yeah, okay, no, not translated. And it says that something is not working. It's probably this thing. Then we need to pass that as a borrow. Then we can say this is just like that. And this is like playing basically whack-a-mole with types, which for some reason annoys me. And yeah, who owned maybe ref to owned. Vec value U32 cannot be built from an iterator of Vec. Okay, so it says that it doesn't like the fact that this is a U32 and not a reference of U32, but we cannot, yeah, cannot return a reference to a temporary value. Okay, so that's definitely not going to work. So how can we make them into a thing? So can we collect them and clone and then connect? Clone. And it says temporary reference created here, reference to data owner. The data is owned by the current function. So who owned maybe? So why is it returning a reference, by the way? It should be returning an actual thing. Oh, because of this thing. Oh, interesting. So that should have been. So this definitely returns an actual thing. Um, so the map is definitely borrowed. That's okay. And this thing needs to just, let's just clone that. That means, and we can pass the clone in and forget about it. And it says U32 cannot be dereferenced, but that's not a U32. I thought that's. Wait, does fold need to return a reference? That's probably not correct, right? Oh, by the way, do we need the map? We don't need the map, right? Oh, we do because we are iterating over all of the seeds. Okay, so so this map. Okay, here what we are doing is we've got our translation map. We're iterating over the maps. We are folding with our state of this seed, which we can probably mutably borrow, but we're not using the mutability of it, probably. And this one is unhappy because it says it cannot be dereferenced. That's okay. And would point that in. No. Why can't I return just like plain old value? More actions. Convert to U32 by the Borel trait. No, that's not interesting. That's not like the solution. So what the hell? Let's actually read the docs of fold. So we've got slice, and then we iterate over that, and we can say as slice, and then next, and that's not fold. What the fuck? Where's the fold? Iterator. It's fold. Rust fold. Fold. Okay, so we've got an accumulator and we just return an expression. So why is this return? It's not returning a reference, it's returning like an actual thing. And we say index clone, and would that free the thing from? Okay, so let's clone everything. Still unhappy. Expected reference found the thing. Accumulator, okay, fold 0, okay, so apparently 0 string, and then we've got an accumulator and refx, and we are formatting. Okay, so let's go over that. This is the map. Let's borrow the map. This is the seed. We are borrowing the seed. Let x be translate. And I just want to return x. And I know like the linter would be unhappy, but I want to understand why does it want a reference where we're doing fold? I'm so confused. So maybe let's just do that then with just like plain old iteration and not with the fold. Let's just do that. I mean, we're wasting time on like specific Rust syntax when we could just be solving the problem. So let's just do that. So we've got seed and translation maps, and everything's very good. So let's actually also create let mute layers, so we'll have them. So that's going to be a vec of U32s, and that's just going to be vec seeds. That's good. The first layer is going to be seeds. That's very nice. So for map and translation maps, we are going to do this. So we could say just let layer be map iter sorry, seed. So we basically want to advance the we always want like the previous layer. So so layer last unwrap, that's okay, and let translated be layer iter map over, yeah, exactly this thing. And all we want to say is layers push translated. So we've got all of our layers now. And let's look at the actual layers now. So this is for each seed instead of, okay, so the first seed, ooh, okay, so this is transposed in the wrong order. So let's actually do this for each seed. So for seed and seeds, we've got no, actually, this is the correct order, is it? Let's think about that. So let's just start with an empty vector. I think let's just do literally vec new. And our layers are going to be, there is no layer for just for each seed and seeds are going to create all of the mappings. So seeds filter for each layer push. For yeah, let's okay, never mind. I'm like transposing for no good reason. So we can actually add seeds as the first. So vec. So for each map, okay, so that's going to be let previous layer be this thing, and for each of the previous layer, we are going to iterate over that, apply the map over the next layer, and collect that into a vector. We don't need this mutable thing, and we just push it. And it says that we are missing a semicolon. Okay. So we do have now all of our layers. So 79, 81, 81, 81. So 2, 2, 2, 74, 78, 78, 82. 74, 78, 78, 82. Okay. So and I see this one is translating to 4 for some reason. And that is why we got it wrong. So the lowest location number. So first of all, wait, what is location is the last one. How come we actually got like to number 4 here? Does that make sense? Let's look at that. So we have seen number 4 already before that. 3, 3, 3, 14, 14, 14. Okay, so first of all, we can remove that. That's not interesting anymore. So 14 gets translated into 14, which gets translated into 14, which gets translated into 3. So the third translation layer is, look at that. So we've got 14 translates into 14, translates into 14, translates into 14, translates into 3. So 1, 2, 3. So it was 3 transitions. One, wait, that's the initial condition. One transition, that's the second one. Okay, so 2 transitions, and the third one is translating it to 14. So let's look at the next transition then. So fertilizer to water map. So 14 is somewhere in the range of let's see, 11 to 42. Okay, so that's the range that we are in. So that should have been translation 0, and for some reason it is not. Oh, it's offset. Sorry, it's offset minus 11. And 14 it is offset minus 11. Okay. And then the next layer is 3, which is out of bounds, then gets translated into. Interesting. So let's look at what are the error conditions then. So I think our translation is not doing we are misinterpreting the translation. So any sources that aren't mapped correspond to the same destination number. So the seed number. Okay, so this is supposedly fine. Are we doing the lookup wrong? Because like most things translate well. Wait, so the lowest number in this location. So, oh, okay, let's actually look at that. So 14 gets translated to 14, then to 53. Ooh, okay, so this is where we got things wrong. So this transition actually is wrong. Let's look at that transition again. So soil to fertilizer should have been 53, and instead, and it is instead 3. So soil to fertilizer. Let's read that very carefully again. So we are number 14, which means that we are somewhere in this range. And for some reason, we are not mapped correctly. So why is that? First of all, I can see the offset is, well, plus 39. So 14 plus 39 is 53. So this map is not parsed correctly, which means we need to debug that parser. Okay, so let's go over this. Where's our test maps thing? Let's add another map. Wait, we already test this map? No. So soil to fertilizer. That the one that's where do we get lost in translation? So we got seed to soil 14 to 14. That's okay. Then soil to fertilizer 14 to 53. So why is 14 to 53 not working? Let's test the translation with the other map. So soil to fertilizer. Let's actually look at the assertion that we've got. So we say 15 maps to minus 15, 0 to plus 13 maps to plus 39. And that is here. So here we've got 0 to 15 minus 1. So 14 is actually the edge case. And that says that is mapped to 0. Which means that our lower bound, our upper bound should be excluded. Let's actually now assert the test. So if we go back to our actual full-on thing, we've got our layers, and we can say now let last layer be this thing, and we can take, okay, so let part 1 answer be last layer iter minimum. And we've got an option. Why is it an option? Because there might not be a minimum, and that's why we need to unwrap. So let's actually run the test now that we've got our upper bound thing may be sorted. And our assertion is working. So yeah, it was an off by one error once again. That's very nice. Okay, I'm very happy with this solution. Like it is actually using a very good amount of iteration wisdom, and like the fact that we can use like a B-tree map and like do the walk with the upper bound, like with the binary search, is very nice. Okay, so first of all, let's commit that because we've got D5 P1 working, and let's try to submit the answer with our actual input now. So let's do that. Let's paste it in the actual thing. So our input is file d5.c. We paste it in, and let's cargo run that. So cargo run d5, and it says that it could not compile for some reasons. It says feature not supported in stable release. Unstable. It says now cargo unstable. How can we use this unstable thing? Cargo run stable. I know we can run that directly through unstable features. So cargo nightly. Okay, cargo plus nightly. Okay, so cargo plus nightly, run this thing. No such command. Plus toolchain. Cargo does not handle plus toolchain directives. You mean to invoke cargo through Rust up instead? Rust up cargo. Um, um, is this not like a thing? Okay, so this is not updated, which is kind of annoying. Z unstable features. Okay. So we could try that. So cargo build, or actually, let's just run directly. Where's our run thing? D5 and dash the unstable features. May not be used on release channel. Rust use nightly. Nightly by default. So this does not work. Rust up override set nightly. Okay. And run. That's quite annoying. Let's just run that directly through our CLI and not think about that for now, because I'm running out of patience. So we've got our configuration, which is run AOC, and we just want to change the arguments. So let's edit the arguments and let's add. Oh, okay. So run packages. I'll go run packages AOC, bin AOC. And we, okay, never mind. So D5, let's run that. And it says, oh, that we've got some errors. Traceback full. Okay, so attempt to subtract with overflow. We haven't solved all of our panics yet. Interesting. So first of all, I've got attempt to subtract with overflow. We've got exactly one place which subtracts, which means that it would be quite easy to find that, but yeah. Panic format, Rust, blah, 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 blah. Oh my God, so many stack traces. Main rs, mod, blah, blah, closure. Where's our actual function? Mod. Yep, that's the one. So destination as I32. So first of all, let's just do I64 then. Just so we will just have better precision. And that would give us an category which has an I64. And then our category would need to be converted into something. So every place we see an I32, we replace that with an I64. I just don't want any overflows. And then if we still have overflows, we will find them and deal with them in a minute. So that's going to be some offset as a U32. Would that be enough? We'll find out immediately. So that's going to be an I64. And it says that translation maps are of type this thing, and here we are on type this thing. And why is it now unhappy about this? What happened? First of all, this needs to be I64. And this also, okay, so that's where like having a type alias is nice, because that would have been okay. So let's actually so let's convert that. Can we like extract this type? Yeah, never mind. Okay, so we've got still, we are panicking on attempt to add with overflow. Mod rs. So let's run that through a debugger then. And let's look at our data. So we've got our category, which is offset minus crazy number, and range length is crazy number, and source is crazy number. Type, please. Typing. That kind of typing or type alias? I'm not sure, but we could extract the type. So let's do the extract the type, and then so let's do that. Let's replace all of these by B-tree map. So B-tree map, replace all, and we do need our type here on the top level, which is now going to be type BTM. That's the thing. Yeah, and this needs to be as well B-tree map. By the way, can we use now the type alias directly in order to make things like, would this work? Yeah, that's very nice. And Okay, that's nicer. Now, stop and rerun. So it's going to be the same values every time because we're panicking exactly in the same spot, right? Yeah, we are panicking, and here we've got the exact same numbers. So this number is like crazy high. Like, what's the log 2 of this? Do we need to have like 64-bit integers for this thing to work? Copy value, and let's log 2 of this thing. Oh shit, we are on the highest bit of everything. Ooh, that's gotta hurt. Okay, so we don't do the 32-bit integers here. Apparently, we are doing 64. Um, okay, they have given us like crazy data to work with, basically. Huge numbers. So our algorithm is probably fine, but we need to replace everything with, okay, so here we need U64. Then every place that we see U32, we are replacing it with U64. So U32 replaced with U64, replace all, and that is probably going to work. We should not have overflows here. Ooh, nice. And we've got a crazy number. And this crazy number is maybe okay, maybe not. Let's submit that. Gold star! Yay! Okay. So that's a victory. Wow, that's very nice. This is actually like this was like terribly terrible, but okay, we won this thing. Let's continue to part 2. So everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes the range of seeds. So the value on the initial seed line come in pairs. Wait, what? So the values on the initial seeds line come in pairs. Within each pair, the first value is the start, and the second value is the length of the range. So if in the first line of the example above, seeds 79, 14, 55, 13, each one describes the range. Okay, that's reasonable. And now, rather than considering the 4 seed numbers, you need to consider the total 87 seed numbers. In each of the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer 84, blah, 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 blah. Okay, 46. What is the lowest location number that corresponds with the initial seed numbers? Okay, so this should be probably like 10 more minutes of actually doing stuff, but let's actually make that happen. So firstly, we don't need to change anything about our code to make this work. All we need to do is reinterpret the our seeds, basically. So instead of okay, so first of all, let original seeds just be this, and we don't have to like compute all the intermediate layers. We just did that for debugging, but we will try to keep that as long as our memory doesn't explode. So firstly, we've got all of our layers with our original seeds. Now let's actually do these as ranges. So let seed ranges be so we need pairs. How do we get pairs out of seeds? So is it chunked? I think chunks of 2. So seed ranges is, yeah, exactly this thing. And now that we've got our chunks, we can actually map that into oh, actually, you know what? We can literally just iterate over that. So we've got our seed ranges. So let's, instead of this for loop, so we've got start range. Let's unpack that. Original seeds. Why is it unhappy with this? This is a vec of U64. So for each one of that, we are going to do the same iteration, the same kind of iteration. So that means that for start end, yeah, that's good. Start plus range. That's not the way to do that. I feel like I need to maybe look at what's the API of chunks. So we've got chunks. So that gives us a chunk object. And how do we use chunks? So we've got an iterator. And we can say next on that. Okay, so wait, lorem. So we get lorem. So first of all, we need chunks exact. So we actually, you know what, we don't need to. We can assert that this is not happening, but chunks exact, there's probably a thing. So chunks exact, yeah. So that's an iterator already, and we can say for each on that, for each chunk, which we can split into exactly start and offset. How would we do this cleanly? I mean, instead of actually, okay, so we could literally chain that into the thing here because we're iterating all over all over the seeds. So we could just add that as another layer. So let's actually just do that. So let ranged, that's going to be original seeds chunks exact. Oh, we don't need this. We just have seeds. That's enough. Chunks exact 2. And that is going to be, we need to flat map that into, yeah, this thing, exactly. So basically start, not end, but end is going to be chunk 0 plus chunk 1 minus 1. No. Let's think about that. Yeah, it is minus 1. And that is going to be a range, and we can collect that directly into the thing. And that's a flat map, and we need to collect that. And we should get a vec of U64s of, well, this is our ranged thing. And we could literally apply that now to another layer. So let mute this thing. I'm going to be like extremely lazy. Extremely lazy. Yeah, and this is just going to be ranged layers. And our memory is going to like just gonna explode. And let to answer the range layers, min, unwrap, yeah. Why is it different here? So last, it's different. Why is it different? So our range layers, that's incorrect. Oh, that's not incorrect. So range layers, back, this thing, same thing. What's the difference? Would be no difference. Oh, so sorry. Let last okay, so last unwrap, it'll mean unwrap. Okay. And let's pop that in here and let the compiler do its thing. And it is complaining about value moved. Why is it moved? Because we're using the same translation map twice. So we are borrowing it once, and let's borrow it twice. And we've got running solution. Ooh, now it's grinding. Activity monitor. This is actually going to blow up. Yeah. Let's look at the memory. So we've got 4 gigabytes of like crappy things. Because we are doing like this crazy range thing. 6 gigabytes. Ooh, 7. Ooh. Okay, so if this won't converge like in a few seconds, we will try to like actually optimize this. Okay, seems like it would not. Let's actually try to debug this while this is running. If this will actually finish, then we'd be happy, but I can't promise you that because I've done like terrible things here. So instead of actually doing this in the terrible way, by the way, what's the actual size of this? This is probably like insane. So instead of collecting that into a vector, which by itself is like crazy amount of like work to do, let's actually fold it now. So we've got fold, which is flat. Okay, we flat mapped everything, which means this is now an iterator of all the possible seed values. And we are able to now, for each one of these, we need to map that out into a seed. And instead of translating that like so, we need to do this translation map chunks exact. By the way, it might be possible to actually like compute a translation map, which is just literally the result of all the like the intermediate translations without actually doing like all of the intermediate steps. It is probably computable quite easily, and we will try not to be too smart about that. By the way, how's my computer doing? Okay, so this one has already tried to allocate 16 gigabytes of memory, and then it says, oh, that's not important. Okay, so this one is basically blowing up because we are saving all of these steps for all of the numbers in between. Okay, so for each translation map, we will do this. So we need to map that. So translation maps, fold. Start with the seed map, translate. And then we need to do something. So this is not going to be a vec of 24. Let's just actually. Okay, so this is now a map of a flat map of something, something. And we are already doing this. So we can just literally take the minimum of that. And we can unwrap that. and that is going to be a U64. And instead of all of this crap, this should have been the thing that we did in the first place. But now the compiler is going to be angry at us, and I will need to debug that. So let's kill this. And let's rerun that. And now it says that sec B3 map is not an iterator. And it says, means that we need to iter fold. Oh my god, this is actually working. Okay, so now we don't need to collect anything. We are basically flat mapping everything. That is going to grind a lot. We could try to parallelize this actually, because this is now going to, first of all, this is now not going to explode in terms of memory, because we're just iterating over everything. But this could definitely benefit from more cores because there's nothing fancy or mutable going on here. We're just doing a lot of math. A lot of very dumb computations, but they're going to take a little bit of time. Let's think if we can actually find a better way to actually do this translation thing. So for each of these, we need to do something. I mean, we could iterate over each layer and add its translations to the next one. And then we could, interesting. I wonder if we should like print things out to the console just so we'll have a little bit of information on like what's going on. So we've got chunks. Is there a way to like, I don't know, see basically this progress? Actually, you know what? Let's test this fold thing on the solution, on like the part one solution, before we actually go on and actually do the part two solution, just to be sure that this actually has sanity. So instead of all of this, we can say let part one be seeds chunks exact, and no flat maps, no chunks actually. So just literally map on seed, and this should be very quick. So that's going to be part one. That's going to be an empty string, and it says method cannot be called back to unsatisfied trade bounds. Wait, what? Iter. So seeds, iterate, map, seed translation maps. It says consider something. Why is this consideration not happening here? We're mapping seed and we need to not again. Seeds clone. So why is this? Do we need to borrow the seed thing? Okay, we've been in this story before, which means that I might do a very dirty trick to fix it, which is to say, instead of, if this is part two and we are happy with kind of happy with how it went, we could literally do this copy everything and run that here and just go with chunks 1. And guess what? Just do this and start. Can we flatmap it into, so we got a chunk of size thing. Um, can we do this without the collect, by the way? So this is basically just saying, give me the range of this to this, which for some reason gives us a better. Oh, we might actually want to compile that in release mode. Okay, so first of all, is this the same answer? Let's actually test that. Yeah, okay, so our answer was correct and it is still correct now that we've done this flat map thing. So now we are not exploding in memory, which is very good. And let's try to run that again. But instead instead of using debug mode, let's actually do this now. So range to string, which is the same thing, just with an actual range. And edit configuration. Let's build that not in debug, but in release. So dash dash release. And that might be able to give us an edge in terms of performance, which would, it might be like a whole lot better. So it is now compiling everything and it is now running. And how would we know if this actually works? It probably wouldn't tell us. So let's think about then, do we want to be smart about this thing? Because we like this could be crazy. For part 1, you don't need the flat map. I know I don't need the flat map. It solved a Rust compiler issue. I know I know it's not necessary. I know it's a flat map on like a range of size 1 every time. So that's, but it did, if I remove it, just so you'll see it. So if I remove this and I try to compile that again, stop and rerun, it is now like completely unhappy for some reason with like borrowing things and whatnot, which I have no wish to debug. So yeah, I'm going to like basically solves a compiler complaint that I couldn't figure out how to fix. Copilot knows me well when it's about like hack and okay. So now that we've got that out of the way, no, I mean keep the flat map, but instead you can return chunk 1 instead of creating a range. I'm not sure because I think flat map expects to find an iterator. But we can actually, you know what? Oh, we can literally just give it a chunk. No, it is now again unhappy with the seed because it's a reference to or something. Ether, maybe? Yeah. And you see now it's complaining again, or you don't see because it's exactly behind my face. No, I think you should be able to see that. Um, let's just make sure. Yeah, so basically the compiler is complaining and this hack is stopping it from complaining. So yeah, we need that create. We don't need it, but this like is just solving a pain point which I don't care to debug right now. So let's actually print line our range. And that would give us a little bit more like insight into like what are we talking about instead of okay, so we've got okay, so we are progressing. Um, and yeah. Um, and basically this is not where we are sad right now. Also like the flat map on the actual thing. Like this is the place that actually hurts. This is like um maybe instead of like printing this funny thing, we can actually print this, and then I could copy it into a calculator and see what's the difference here. So yeah, this is like 100 million elements. Um, so not that we're going slow. It's just this is a crazy range, and we should have been more algorithmic about it and less how should I say brute forcey about it. But like this would give us a solution. It would just be terribly, terribly inefficient. Um, should we spawn and join maybe threads for each of these? Because like I do have 8 cores, which are basically sitting idle right now. If we open up activity monitor and we look at the CPU, it's like there's going to be like 1 core, which basically is ground to a halt with 100% usage from the advent of code process, and all of the others are basically sitting idle. So let's try to maybe parallelize this. This would be like a very nice way to do this. We're not doing a lot of work for each element, but we do need to like do a lot of work. But now I'm happy that we went with the B tree thing because this is basically because the numbers are so huge. We are we the fact. Oh yeah, it's done. Okay, so let's plug that answer. And the answer is not right. It's too low. Shit. Oh no. So first of all, um, maybe it's an off by one thing. So we might be doing duplicate work, but this won't matter because this translation thing is like will not do a lot of duplicate work basically. Um, and let's try that again. I wonder if it's somewhere on the edges of the ranges. Probably not, but I mean, could be. By the way, I'm quite happy with the fact that this is like not terribly slow compared to like the amount, the like crazy amount of work that it needs to be done here. Um, so, um, what? Let's figure out if we can actually do this in a like parallelized sense in Rust efficiently. So Rust parallelism. Fearless concurrency. So no, we are not doing concurrency. We're doing proper parallelism. Uh, shared state concurrency. No, I want like high performance computing. So Rust, multi-threading. Okay, using threads to run code simultaneously. So we can say just thread spawn and join all of the threads. We could hand out chunks to threads, basically. For each chunk spawn a thread. We don't have a lot of chunks. I think we have, let's actually look at the amount of chunks that we've got. The 5, so we've got, how many spaces do we have here? That's not going to be useful. Okay, so that's not a lot of chunks. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got less than 16 even. So this is going to even almost match 1-to-1 with the amount of calls. So we could say for each chunk on a thread instead of actually flat mapping this. And that would also mean that we don't need to collect this crazy range vector before we are actually handing it over, which also would be nicer, I think. So let's do that, maybe. We've got this thing, and we can literally map that. So let's try to do this. So we've got this. Let's copy that. And we will just do this like ranked. So this is going to give us a map of a thing, basically. And that thing is going to hand us over another map, and we will also compute the minimum on this thing. And this also needs to be unwrapped. And in order for this to work, we don't need a flat map now. We just need a map. Because, well, it's chunked and we are mapping each chunk. We are applying a function to it. And oh, by the way, it did finish. Okay. With the same number, sadly, I think. I think it might be a different number. Submit that. Too low. Shit. Okay, so it was the same number. Okay, but that means also that we've got an algorithmic bug and not before we actually do performance. So let's go back to a version that works, which is this thing. Up to, yeah, this thing basically. So this thing runs, but it's not correct yet. So this is our start and end things. So our end is going to be this thing, and we are mapping over all of them. We are doing the same translation. Are we supposed to do a different translation? Let's just make sure of that. So this is the range. So we are iterating over from 79 all the way through 92, which is let's just 79 plus 14 minus 1. Yeah. Okay. So start dot equals end means that we start from the actual thing. So that should be either this thing or that thing. Yeah, so this is the one. Basically, this would give us actual range. And this doesn't work, then where have we gone wrong then? So maybe these chunks are incorrect. Let's actually look at them. And this one, this chunk instead of start end, let's actually print the chunk. So we've got chunk thing and chunk thing. Let's print that out quickly. And okay, I think we see a problem. This is obviously not what we expected this to be. Oh shit. Come on. Okay, so 118. Okay, so this is actually the thing. And we are doing this from start to end like that. So our end is the actual like start and range. So what's the lowest location number that corresponds to any of the initial seeds? Wait, if it's too low, that means we're too permissive. Interesting. This is totally a thing to write in Python where you have like a Jupyter kernel and you can basically resume the state at every point. You don't need to like recompile and recompute everything from before. But yeah, moving on. Seed is going through the translation thing, and this is known to work because we have computed everything correctly here. So is this problem with the range? Like what the fuck? So chunk dot thing. 339. Again, probably the same as before, right? 339 is the same. Um, so how would we do this? Is this like another off by one thing, basically? It could be something in the translation on like things that are either above, completely above, or completely below. So cursor value, index clone. Interesting. So first of all, let's. I wonder, like, no, this would spam spam us completely. And also here, I don't think we need to actually clone now. I think we've solved that relation issue. I don't think I have a good solution or an idea on how to solve that. Is that the time to cheat? I think it is because it's getting quite late. I think it's the time. It's cheating time. Okay, so I'm okay. This is not a good This is a code golfer's answer. So let's actually see if there are any better spoilers for that. Um, so we are going to find this out in a minute. So let's just go directly to my friend's GitHub, which is Advent of Code 2023 source bin seems reasonable. Day 5 and main RS, and let's figure out where have we been, where have we fucked up. So here it says data seeds into iterator, map seed all mappings, that's okay. Iterate fold seed accumulator. Then it says mapping source contains accumulator, then mapping offset. And this mapping offset, let's actually look at how they do that. So they say before overlap range. Okay, so they do a different thing. Interesting. So multi-map range. Okay, they're doing a lot of other stuff. Interesting. So let's look at the actual contains thing. That's the actual like contains. Okay, so source is just a range. Is there like, oh my god, there's a proper range thing. Why'd they fucking do like implement this over with hash maps? I didn't know that they had like a range, you know. Okay. That's quite annoying. So before overlap after. So there should be no overlap as far as I know. Yeah, let mute overlap, extend overlaps into leftovers. Oh, interesting. So they're doing a lot of like interesting stuff here. Yeah, that's quite sad though. Are we going to actually find a solution that works? Ba, 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 ba. This would also, of course, be faster if you only like query the ranges and not like actually do this lookup one by one. But I'm too knee deep into this solution, which is terrible, but we'll just do that. So just to be sure, I don't know. I'm just like basically whatever. I read. Okay, so this one is now running, and we have cut our ranges just a little bit, just by the edge, just to be sure that we're not like overly inclusive just on the edge. Um, I wonder if there's like a very way to hack this together correctly. So we've got our translation maps, and we are doing this thing. Let's see if we can like actually convert that into the actual thing. So we have our So instead of like constructing this as a map. So pass state. This done. This is done, and it's still the wrong answer. Shit. But this is still the right answer, right? I haven't broken the algorithm or something. Yeah, okay, this is still the correct answer. This is not. Um, pum, 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 pum. Do we want to, like, I don't know, rewrite this algorithm in a better way? Not so much. Would be nicer to actually do this correctly. We could like literally like do this, the like overlay all of the ranges basically. That's the thing that we could aim for. How would we do this? Let's actually think about it. So we've got our map names. That's not interesting because we don't care about them. We've got our state, which is like all of the game, and we do have our category, which is basically all of this. So instead of passing this category like that, we could try to construct all of these ranges and then overlay ranges on top of each other until we are folded, and we have like a set of ranges with known offsets for each one. In each, we don't need the middle layers even. So let's try to do that. So we've got translation layer. What does a translation layer have? It's a map. Okay, so translation layer is a vector, is a map from range to offset. Is that a thing that we could do? Do we have a way to map from a range? Like, are ranges like hashable, basically? I mean, that's what we did with the tree by like doing the lookups, but apparently I got that wrong. It might be something like the inclusive versus exclusive thing, or the edges of the. Okay, so let's actually look at that a little bit closer. So we've got our excluded thing. So what happens? This seems like, I don't know, just like a number. It's hard to know, like because it could be mapped quite a long way. So yeah, this is going to be terrible to debug, basically. By the way, is this like actually here in the input? Obviously not. Because these are ranges as well. So like this is not good. So how do we merge these maps into one map, and then like things become a little bit nicer, maybe? I don't know. I don't have a good idea. Um, this is the actual range. Wait, just to be sure, which one is the start, which one is the offset? 79 is the start, 14 is the offset. First value start, other one length. So yeah, this is the correct way to interpret this. ranges of seeds. The value of the initial seeds come in pairs. The line describes the ranges of seeds. Rather than considering the four seed numbers, you need to consider the total 27 numbers. The above example, the lowest location. Actually, you know what? Let's actually do this test. Why haven't I tested this? This could have been a good test to debug. So test part 2, same thing. Part 2 should be 46. And what is the lowest location number that corresponds with, wait, what? If, how come this has a higher location? I thought this would only go lower. Okay, so first of all, let's run that test and actually debug that. This one fails because we've got 47. Pum. And now let's actually fix our intentionally put off by one error here. And things will compile and actually test correctly. No, they still are 47. Interesting. Very, very interesting. So we are off by one for some reason. Not sure why or how did we reach this. Do we need to say this for some reason? And it says, oh no, that's syntax error. So that's very curious. Like I'm very, very curious about this. So we are starting with seed. We're translating everything correctly, but now we're just passing new coordinates. So first of all, let's actually dbg this seed. And got a lot of debugging, and we are seeing 79 to 14, and then 55 to 13. So where's 47? Could be here somewhere. Is it here? It's not, because it's not the seed number, it's the translated number. Oh, shit. So we need to also debug the translation. So that is the one to also debug. And we've got 47, which comes from seed 83. And this should be from seed 82. Okay, so why are we off by one like so? That is very, very, very interesting. So is this chunk thing not doing what I think it does? I've seen the thing. Like I know what I can literally do. I can do -1, and this would fix everything. But why though? Okay, never. Okay, I'm not asking questions. I'm running this on the full test. This is what I've devolved into. Okay, so we've got start, and this is our range. And let's just run that without, of course, these debug prints, which print out on every line, and not actually run the actual test. So run. This is running in release, right? Yeah. Okay. And hopefully this will just we were like off by one on the wrong end of like where off by one things happen, which is very, very weird. Um, I'm so confused. Um, if this somehow solves it, I'm like I will be pissed off, but I will also be happy for like being done with this because this has been taking quite a long time. Um, so while this is running, I'm not gonna do like the proper algorithm. I think this is going to be left for either future me or no one me, no me. Um, but I'm actually happy that most of today was actually about algorithms and not and like about actual and not about like passing, which like I really have no patience for actually like doing more and more passing now. Um, could do like the whole multi-threading thing which I talked about, and then I never got to actually do. Shit, it's the same number, right? Please let it be a different number, and that would work. Too low. Shit. Um, well, um, I think that's all for today. I'm very, very tired, and yeah, yeah, I'm very sad. Um, I think that's all for today because I mean I'm like too fucking tired. We got like one solution down. I need to like go back and do my homework and actually like implement this correctly and not like do the O of the amount of seeds times the amount of maps times the amount of lookups that it takes to do this algorithm now. Um, and yeah, I need to basically just do like range lookups instead of like actual per element poking. And then things would be better. And I'm just like not in the mood for that. So yeah, thanks for joining in very much, and I'll see you maybe tomorrow. Bye bye for now.